Hello and welcome to the Six Sigma Green Belt Statistical Tools video. In this particular video, our aim is to brief out all the tools used in the application of Six Sigma process. First of all, let us understand what is Six Sigma. It's a tool to control the counts of defects. Defect is any non-conformity in the product or process. Six Sigma aims to achieve 3.4 defects per million opportunities, which means if a million units are produced, the number of defects must be less than or at the max 3.4. Now, when you apply Six Sigma, there are 5 stages that you need to pass through: define, measure, analyze, improve, and control. Before you apply Six Sigma on any part of the process, you need to understand that it has to be an area which is critical to customer, it has high impact, it requires a team approach, and it demands a duration of 3 to 6 months. Only when these 4 criteria have been satisfied, you can work on the Six Sigma part. Once you have decided the aspect or the indicator that you need to work on, we start with the define phase. In the define phase, you need to have a problem statement. Very particularly, it would specify what exactly is the problem, where in the process does it occur, and what is the frequency or when does it occur. Use voice of customer to convert it to critical to quality parameters. Define the scope of project. Come up with a detailed project charter. Project communication plan is equally important. You should have a team structure with specific roles and responsibility assigned to each member, and you should also have the specification limits provided to you by the client. Now, the tools used in define phase are SIPOC and Kano model. The Kano model actually lets you know which aspect or which need of the customer are you actually satisfying. If the key performance indicator that you're working on which you are applying the Six Sigma project lies in performance needs and excitement needs, that is what we are actually looking for. If your key performance indicator lies somewhere in the basic needs, that means the product is not even satisfying the basic need of the customer. So that is a wrong selection of Six Sigma process. Hence, Kano model lets you know which need of the customer are you trying to satisfy. Moving to the next phase is the measure phase. You need to understand how to measure the parameter, what shall be the units of measurement, is the measurement tool valid or not. You need to collect and analyze the data, provide baseline values, and set the benchmark values. The tools used in measure phase are FEMEA, Gauge R&R, histograms, control charts, process capability and performance index, and Sigma rating. Starting with failure mode and effect analysis, it aims to uncover the problems that may result in failures. Now, there are 3 aspects to defining the failures: the severity, the occurrence, and the detection. Each of them is rated from 1 to 10, and you multiply all 3 of them to get the risk priority number. This lets you know how significant or what is the effect of the failure occurring. Next is gauge R&R. It is used to measure the capability of the measuring system. Repeatability and reproducibility are the 2 aspects that we try to measure here. Repeatability denotes the variation due to the gauge, the equipment of measurement, and reproducibility denotes the variation due to the operator, the person who is measuring the attribute. So you need to find out the variation due to the gauge and the operators. The tools used here are average, range. They help you find out the variations. One can also use ANOVA to distinguish between the variations due to gauge and operators. Next tool used in measure phase is histogram. Histogram lets you know the shape of the data, whether the data is unimodal, whether the data is skewed, or whether it has bimodal. This lets you know whether further tools can be applied to it or not. Most of the time, the indicators follow normal distribution, and it is easier to find out the sigma rating for them using the normal values, the Z table. But in certain cases, the data you got is sometimes skewed or it may be bimodal. In that situation, it is important to transform the data into a normally distributed one before you can apply any further statistical tools to it. Hence, histogram gives you an idea whether you can proceed further or do you need to transform the data before you proceed further. Next comes the control charts. Now, at this point, it is important for you, being a team member for Six Sigma project, that your main aim is to understand the data you have and which particular control chart is the best used for this particular data. So decide whether the data is quantitative or qualitative. If it's quantitative, you can use X bar charts. If it is qualitative, based on if you're counting defects or defective, you can use C and U chart or NP and P chart. So what understanding you should have is what kind of data you have and which control chart specifically applies to it. Once you find the specific control chart, you can just go through the tools of the software and click on that chart and get the control chart. The interpretation of all the control charts is exactly same irrespective of whether it's for defectives, whether it's for quantitative data, or whether it's for defects. The second last tool that helps in measure phase is process capability and performance index. Now here are two things that we need to focus on. The first one is design width and the second one is process width. Design width is the difference between the specification limits provided by the client, whereas process width is the variation that your process has. So process capability CP is nothing but design width divided by process width. Design width is USL minus LSL. USL stands for upper specification limit, LSL stands for lower specification limit. The denominator is 6 sigma hat. Sigma hat here is the estimated standard deviation. 6 times of sigma hat gives you the process width. So CP is nothing but design width divided by process width. It gives you the capability of the process. It is expected that the design width be always greater than the process width. Only then we call the process to be capable. Hence the value of CP should be greater than 1. Further, you can also calculate CPU wherein upper specification limit is subtracted from the mean and CPL wherein lower specification limit is subtracted from the mean. The minimum of CPU or CPL gives you the performance index. It is denoted by CPK. CPK is equals to minimum of CPU or CPL. Thus, with the help of CP and CPK, you can find out the process capability and performance index value of the given process. Remember, presently we are working to find out the parameters or the performance level of the present existing process. We are not doing any improvement at this point, just measuring the existing process. Last but not the least, another tool that helps in measure phase is sigma rating. To calculate sigma rating, all you need to do is find out the number of defects in 1 million units produced. Once you find the value of defects per million opportunity, you subtract it from 1. This value gives you the probability under the normal curve. You find out the Z-score for 1 minus DPMO and add 1.5 to it to get the final sigma rating. You can always find out certain online templates to calculate sigma rating directly in Excel or any software that you're using. Moving to the next phase, analyze phase. In this particular phase, the root cause analysis of the entire process is done. The major causes, control factors are analyzed. The basic or the most useful tool at this phase is brainstorming. The more you brainstorm and find out the maximum number of causes, the more helpful it would be for you to trace the real root cause of the problem. The tools used here would be cause and effect diagram, hypothesis testing, and correlation and regression. Cause and effect diagram is also known as Fishbone Diagram. This is how it looks. You are aware of the problem and you know what all inputs come to it. The inputs may have various causes, innumerable causes can be there. You need to trace out all the causes and the root causes beneath them to actually rectify the problem. Hypothesis testing is a tool that is used to test the beliefs or any particular value that you have in mind, and you can test it for one sample or two samples. If you're working on one sample with mean, you can either use a z-test or t-test depending on whether sigma is known or not. If you have one sample with a proportion data, you can use one proportion z-test. If you have two sample data to be compared to each other, you can work on two sample z-test, t-test, or two proportion z-test depending on whether you are working with mean or proportion. Hence, you can observe the different types of hypothesis tests are provided to you, are available at your end, and you have to figure out which one fits in for the given scenario. So your aim here is to be able to interpret or understand the data you have, whether you have one sample or two samples, whether you're working for the average values or the proportions. Based on that, you select the correct hypothesis test. Further, what is important is understanding how to interpret the final outcome. The outcome will have two important values to be referred to. One is the test statistic value and the second one is p-value. One can draw the interpretation either using the test statistic value, which is called critical value approach, or one can compare the p-value and draw interpretation. It is called p-value approach. P-value approach is a standardized approach that works on all the different types of hypothesis tests. By default, level of significance is considered to be 0.05. Decision rule is that if p-value is less than 0.05, you reject the null hypothesis. Hence, there is significant difference in the two observations or from the preset value that you have. Moving ahead to the last tool of analyze phase, correlation and regression. Here your aim is to create a relation or identify the relation between the y and x, where x is the independent variable and y is the dependent variable. Y is also called the response variable and x is considered as the predictor variable. When the x values are attributes in nature, ANOVA is used, but when the x values are continuous, in that scenario, regression and correlation analysis is more useful. The various values that are very important for you to analyze our correlation coefficient are, it tells you about the magnitude and direction of the relation. So if the value of r is -1, there is a negative relation. If the value of r is +1, there is positive relation. If the value of r is 0, there is no relation. Linear equation of regression line is given by y equals to mx plus b, where m stands for slope and b stands for constant. You will get these values once you run the regression analysis directly. All you need to do is be able to interpret these values. Like r will tell you the magnitude and direction. M will tell you about the slope. B is the constant value. Likewise, the last value that is important for us is the coefficient of determination, which is nothing but the squared value of r. It tells you about the percentage of variation in y explained by the x, the predictive variable. So suppose if the value of r square is 89%, this implies 89% of the variation in y is explained by x. Now suppose the r square value is just 12%. That means only 12% of the variation in y is explained by the x value. So by analyzing the r square value, you can decide whether the model is effective in predicting y or not. Basic formulae are not useful as softwares like Minitab, SPSS provide direct values. You need to know how to interpret these values and draw inferences based on it. Moving on to the fourth phase, improve phase. In the improve phase, now you have to understand whether y equals to mx plus b model is available or not. If it is available, you can directly apply the optimization techniques and find the best values of x that help you find the value of y. If the model is not available, you need to figure out, is it feasible? If it is feasible, you will try to create the model by changing the design of the entire process. That is where design of experiments come into picture. But if the model is not available and not feasible as well, you need to use other techniques which are not under the curriculum of Six Sigma Green Belt. Moving ahead to control phase, the final phase, the main objective is to hold the gain. Use the final process capability value and final control limits to evaluate the process. Create the SOPs for the people who are going to run the process in future. Perform the financial review to monetize the improvements achieved. Hand off the Six Sigma process to the process owner. With this, you can complete the Six Sigma process by employing all the statistical tools and using them in the right manner to make your Six Sigma project a success. Thank you.